thanks for inviting me. I don't think I've attended many JS Roundabout events, but I've basically been, this is what I wanted to talk about, Node.js on serverless. And hopefully, I don't know who's using serverless. Is there anyone using it? My guy. I have a friend. I have a friend. Okay. No, I'm more friends with you, don't worry. So I'm Ulpian. I do a lot of things. Most of the stuff that I do is programming. That's about it. I know I have Twitter and GitHub links, but email is probably the only one that I really respond to. This talk really is about raising more questions than giving answers. So I'm sorry about that. This is not about the serverless framework, if you have checked it out and if you have sort of seen it. And it's also sort of learnings in the last year that I've been leading a sort of team. We've been doing this project and we just decided to say, let's just use Lambdas for some reason. And it has quite a lot of things like DevOps stuff for a code talk, so bear with me if you really hate DevOps. But it's all good. So we started this project and we decided to go with AWS Lambda because for a set of reasons. I mean, it's modular, it was scalable. We didn't want to maintain a lot of things. We wanted to free up developer time. Also, the project was run partly by a team that was an agency, and they kind of wanted to make sure that they can reuse code and take this to other projects. And also because it was cool. That's the other reason I have to list. And so usually what we have is when we're setting up a project, we usually have something that kind of looks like that. I know that's very simple, but it has everything in there. It has a source, maybe some docs, has a nice test folder. It's all in one place. Our index.js God file is there and everything. So that's kind of what it looks like. And that's what the team had been used to. That's what kind of we were being used to, and that's what we knew that wasn't going to be the case if we were going to move on. So we looked at AWS Lambda. This is the kind of response we got, which is AWS Lambda is a compute service that runs your backend code in response to events. My first reaction was, that's kind of everything. Everything responds to an event and everything is a compute. So anyway, what it really kind of is essentially it's a cloud platform, and it's running a sort of a series of EC2 machines in the background. It's running Amazon Linux. This is the Linux kernel for v4 Plus. That basically essentially manages the execution of containers, Linux containers, and container being an execution environment. And what it does is it takes your code, it basically puts it in one of these containers, and you have a whole sort of configuration around how you want to run this code and how it should be. It basically starts that up and tries to freeze it in case you have subsequent sort of requests coming in to try and make it as efficient as possible. However, this is erratic because it doesn't know when it's going to die. It doesn't know when it's going to live either. So it's kind of, you can't really depend on it, but that's how it runs. So low level, that's essentially how it kind of is as a summary. So it's essentially, the idea is that you can write your code with the team and not care about how this is going to be configured in any real way. You can connect DNS and everything, but in terms of the server and in terms of sort of all the configuration around that, all the maintenance around that, and all the scaling around that, you don't really need to care about that. You just write some code, some logic, and it's gonna sort of run. The problem is that little piece, when they say everything else runs fine, that piece is not totally true. And I wouldn't trust anyone that tells me everything is going to be fine. But essentially, the cool thing is that events can be anything. It does run your code pretty well, actually. And those events can be HTTP requests, events from other Amazon services that they run. Could be a JSON file. Supports v6 of Node. And also, very importantly, usage is measured in increments of 100,000 milliseconds. That's basically the execution time of the Lambda itself. So if you have your code, you have some logic that's going to run there. It basically takes in a request. The event could be HTTP, so you have an API service. That starts executing, and then it's measuring per 100 milliseconds. So if you have a long process, or if you have any kind of bottleneck or anything there, that's going to start costing you money. So when we looked at Lambdas, we knew that this was going to have to be a sort of microservice approach. We knew that we were going to have to build small pieces of code that can communicate with each other. This definition here, which I think is pretty good, says microservices is an approach to application development in which a large application is built as a suite of modular services. Each module supports a specific business goal and uses a simple, well-defined interface to communicate with other sets of services. That, I think, pretty much rounds it off. I know there's no real consensus on sort of what microservice is, and everyone has a general idea. I think that pretty much rounds it off, and I said, okay, well, let's go with what these guys are saying. But of course, that is pretty much a kind of really an idealized situation. And so what we found out was that, first of all, from the idea of microservices and from the services that were on Amazon, it kind of mapped really well. So if you're not aware of all the services on Amazon or what they do, they have a pretty good service called API Gateway, which is essentially like a HTTP server load balancer. It does caching as well. It's very, very powerful, and it's quite easily configurable. Then you have what API Gateway calls APIs, which we believed mapped to resources pretty well and the routes. And then the Lambdas themselves could be basically endpoints in an API. So if you think of this as a sort of vanilla REST kind of structure for an API, you can say, okay, I've got my resources, I've got the endpoints that are going to execute. Each of these endpoints kind of serves a specific business goal or a specific sort of action, and that can be well defined, and everybody will be fully aware of how to scope that and how to write that code. And then you have things like VPC for security and so on. So it kind of mapped really nicely. And so what happened is we started going from that big kind of code base to something a bit more like that. So you have this serverless folder, which essentially bundles up your code base, and it puts it in there. That's what actually gets sent to AWS. And this time what we ended up having is the handler.js file, which is the sort of the JavaScript that will actually hold the logic for that specific function that's going to run in the cloud. And we have this source folder, which is like our services and models. So we broke up the code base into kind of what we were defining as modules. So that one resource would be one module, and all the endpoints would be written as separate lambdas in the handler. I know that says handler, but it's handler. Then I set a standard for the classes and the services and the models, and each model has its own repo. So take into consideration, by the way, that this specific project wasn't Google, right? Like we weren't trying to figure out we weren't building DeepMind. We weren't trying to create this amazing thing. It was actually a pretty small project, and the aim of this actually initially was to get into AWS Lambda because it was a small project, right? And I know that there is this counterintuitivity about if you're doing microservices, you've got to have a big team, or you've got to have at least a fairly big, strong team who doesn't mind cleaning up things and maintaining things all the time, which is the kind of the problem that we went into. But the aim was that if we built these this microservice that we didn't have to care about, then it could be something really beneficial for any other project that we'd be building, or any other kind of thing that you would need. If you have a Lambda that does authorization for you, if you have a Lambda that does image manipulation, Joe, you're mentioning you have Go, which is running all these encryption stuff, then you can basically split it out across this whole cluster, and it does a very specific thing and call it whenever you need to. So that was initially what we were trying to do, and we went with that microservice approach with the hope that, okay, we're gonna, we know what we're doing. We're gonna make this work. So this is kind of what a handler started to look like. This is pseudo, but we basically, because we were creating the models, and some of the modules that we were creating were sort of in their own repos. They were npm packages. Some of them were privately held, we thought that was the best way that we could essentially use this. And so that's exactly what we did. And we have these services. We have even a sort of a wrapper for the handler, because Amazon basically gives you the handler function that you write, gives you a context, and that's about it. And so we wanted to do some other things, like we wanted to, I know you mentioned you didn't like generators, but we put co in there because it's version 6. And we started to realize actually that we're running an API service. And when you run an API service, you need things like a database. You need things like image manipulation services. You need your models to come in and do the validation and all that other stuff. And so we were starting to realize, and this is a year back, so there's things that have changed, but we started to realize that we needed to do essentially what I would call hacks to make this work, right? Like wrapping up the entire function as a co and then giving it to Amazon to deal with. That's not like the best case scenario, but we needed that because we didn't want to work. It would start complicating the situation when we started working with connections and database objects and other I/O operations. And you have to remember, there's no backbone to this. So this is like completely being held on Lambda, right? Like from beginning to end, there's no single EC2 machine that's orchestrating anything. So it started to look like this, where we're like injecting services on this, we're wrapping a generator, and then the response, the self, the callback would hold some other dependencies that are not really clear here. So things are getting really murky, and there's issues. I know this talk is really pessimistic, by the way, but it will get better. So some of the problems around this is some of my favorite ones anyway, is the connection pooling problem. So if you imagine that you have this platform that's spinning up these containers, well, you won't have anything that lasts very long. So we have an unpredictable state of executions for the Lambdas. They blew up our connection pool. We had a Postgres database. I mean, you can imagine any other kind of I/O operation. And we hit like this test. We were running all of our tests on the API, and it just went, and it just went away. It was just 500s everywhere. So what we had to do was then actually build the connection and tear it down every single invocation on the Lambda, which again, just it feels bad. You can realize I haven't had a good sleep for a whole year. And the other one was VPC and cold starts. So essentially, the other problem is that Lambdas go cold because they cost money to run. And when they go cold, what I mean is that the container in which was first created is going to go away, right? Because if you're not like Facebook or something, then you're not going to get requests every single second or every 10 seconds or whatever it is. So they essentially go away, and what you need, and they need to start back up again when you make another request that comes in where there are no containers. So imagine all these containers have been spun up, they die down, and then somebody enters your website and wants to do something, that hits the API, and then they got to wait because that container's got to spin up. And to run that kind of operation does take computing power. This isn't a smart solution, and believe me, in the serverless community, there is not a smart solution for this. We basically ping it every 5 to 10 minutes. We're basically like annoyingly nudging this as much as we can. We keep pinging every 5 to 10 minutes to try and keep at least one container open so there's an invocation, right? So you can imagine our sweet little hearts at the beginning of this project thinking, oh, we're going to save money. And then we get to the point where it's like, wait, so we're pinging it anyway. So we're automating EC2. Anyway, it gets dark. But a VPC cold start takes up to 10 seconds to warm itself up. So if you have these Lambdas, if you have your whole infrastructure that you've set up and you have a VPC around that because you really want to be secure, then it's going to take up to 10 seconds to warm itself up, which is slow, right? I mean, like we get freaked out if it's like 800 milliseconds or 500 or something. So 10 seconds is a long time. The other thing is, and I wanted to put some screenshots of people having problems on Stack Overflow and so on, where they're like, oh my God, like I wrote the perfect code, but it comes back 500. And it's like, well, the problem with that is the way that these containers run, the way that Amazon runs your Node.js process is that it obviously simply runs Node as it is. And what it does is you can change the execution time. However, the way that Lambda realizes when you're finished with this Lambda, with that Lambda, is by actually checking the call stack and the event loop. And if you have something in there, then what ends up happening is that it blows up because it's past its execution limit. And so the problem is that if you imagine a developer who's kind of just used to opening up a database connection, hoisting it, above the application code, and it's some code that's checking for a pool or checking for something on the side, that's going to keep jumping into the event loop, right? And it's going to keep sending things in the call stack and saying, is it alive, is it alive? And so, Linux comes to this point where it's like, well, it's never finishing, but I have this hard limit and I got to kill it, and it just returns a 500. Well, API gateway is returning 500. Your actual Lambda is dead and buried. So there are these kind of problems that I think people hadn't quite realized, because they kind of shoehorn the concept of just a machine or a server into what is actually a container, and they get these problems. Then there's this, so I'm not even going to talk about this. Phil, if you have another talk, maybe I can, because this is a long one. Yeah, testing is horrible. Let's do it. Just leave it at that. So this was getting annoying because there was a lot of issues, and I think that actually the problem is the way that we think about microservices, the way that we think about code and API services actually in general. And one of the reasons when I was speaking to Phil as well, where I mentioned to him actually, and why it's written on the event, that the benefits of Node.js, and why I was questioning that when it comes to Lambda, is because actually Lambda, and I personally think all sort of microservices are very good for executing some program, some series of instructions for a very specific reason. And in a way, Node is a fast sort of engine. You can execute code very quickly. But Node actually is also one step before that. It's a really good job queue, right? It's like it's an orchestrator for you. And so one of the problems was that when we were getting to put this up on AWS Lambda, we weren't realizing that what we were doing was we were putting already a very good job queue into a wider infrastructure that acted as a job queue. I mean, API gateway in a way is a certain queue, right? It takes certain requests, and it does this really, really well. So that's one of the conceptual problems that I think we were getting at, and I think that Node.js still is amazing to use in Lambda, and you should still do that. It's just that the way that you use it, right? And the way that you think about how the service is actually running. And to Amazon's credit, they do mention that AWS Lambda is good for running web services in a paragraph, in a very vague, product-selly paragraph. But most of the time, they're actually talking about image manipulation, they're talking about encryption, they're talking about CPU-intensive tasks. So actually, you can imagine yourself building a web server with Node.js and then having any I/O operation be some Lambda that does some heavy task, right? In our case, we were trying to run the entire API service on just Lambdas. So that I think took a bit more lessons than we realized. So what I think is going to happen, and I think what is happening right now, is that the majority of developers that are using serverless applications, they won't be going through the microservice approach because it's hard and we're lazy as people. So what they're going to do is still leverage serverless architecture. And the way that they're going to do that is, for example, very recently a tool came up, which is what you're seeing over there, called Up. It's written by TJ because he writes everything. And basically, it's essentially a proxy service. So if anyone's used Heroku, this is your way of doing Heroku, like in, I don't know, like 10 seconds, 5 minutes, something like that. Like you can have an entire Express.js or Koa.js sort of server running, and what happens is it packages that entire application without any other configuration for serverless or microservice sort of setup. You're running it as it is, and it packages that up, and then it basically proxies the request that you would get into your Express.js or Core.js app, and it basically shoehorns this into a Lambda, and it takes this out and deploys it. Now, the reason why that works is because it actually turns out that it doesn't matter how many Lambdas you have. If you have one Lambda, it's fine, because ultimately AWS will spawn these out as containers. So if you have your entire application in one Lambda, it'll spin as many containers as needed for that. Now, there are caps for this, by the way. So I think it's something like 1,000 requests per second. There's a cap, and I think if you call them up or something, then they'll increase this for you. But the point is that you only need one version of your code, and it'll still function fine. If you have 10 Lambdas, or if you have one, the scaling is the same. So that's one reason why it'll work. But really importantly, so basically what these guys are doing in the AWS Lambda world is useless, because all you need is one container, not all of them. But this brought me this question and this point that actually it changes the way that we're writing JavaScript, and it changes the way that we're sort of designing our web services. And then the logic that we ultimately write is very different as well, because the way that we're writing dependencies and the way that we are sort of pulling in libraries and so on becomes really different. I mean, when you're writing a web server and you have that one instance and the machine is going to be running fine, you can hoist your dependencies, you can pull connection, you can do all of these things, and you know it's going to be cached and you know it's going to be fine. That's not the case now, and we have to think much more stateless. We have to think much more functional in order for this to work. But I think that people, as I said, because we're lazy, I think we can build our application the way we've been doing now and use a tool like Up to basically just push it up into Lambda and think we're going to be fine. So, looking back on this, there was a sort of, like, I've been thinking about a sort of proposal of what we could do, and just thinking about how, if we are if it's too hard to maintain a large series of code bases around modules to build our API service, how do we make a lazy way to make that possible, right? So I think that the way we do that is we have to build functional stateless code bases. And is anyone here aware with IOC, inversion of control? Right. So basically, the idea is that we build out classes, for example, or objects, and we push out the control not in the class itself, but to the module that we're requiring, right? So, for example, an ORM is a perfect example of this. We could have any sort of database that we might be working. The interface will be the same. We expect a certain interface to function in a certain way. And that really makes things much more functional and much more stateless. And then we basically build that out into something that runs a HTTP server for testing locally, and is decoupled of all its modules for deployment to Lambda, but it does this behind the scenes. So I can show you an example of this, but if you have a code base and you're using a concept like IOC, it means that you can list out your dependencies. You don't really care where they come from. You're just injecting your dependencies. They come into all your classes, and then you purely care about the logic. It's still one code base, and I'll show you an example of this. It's still one code base, but behind the scenes, we can take out these modules because they're so cleanly decoupled, and we can do the kind of boring and also just long work of taking this out and putting it on a Lambda and then doing the rest of the configuration stuff. So APIs that are scoped around resources, Lambda handlers can become the endpoints. The APIs can, the gateway APIs can take those as resources the same way that we've done it. It was not a bad idea. It actually worked very well. It was just really laborious. And also monitoring and metrics are easier. They make more sense when Lambdas are split. There are a couple of small projects that are using that tool which I showed you up. It just takes your entire thing and proxies it, but the problem is error handling becomes a huge issue, and there's just no way to see what's actually happening. Monitoring becomes even bigger problem. Proxying services like that also, they add 500 milliseconds to the round trip, up to. Right? Most of the time it is. You know, when people say up to 500, it's like it's always that. So they always add that to the round trip, and also I don't know. There's something dirty about the idea of shoehorning an entire application in Lambda. Maybe I haven't got around to that yet. Also, the nature of Node.js fits better with this concept. It was actually really interesting seeing your point about CSP, because I think things like that can be definitely used to kind of inspire the thinking of how do you get these two pieces to work together? How do you get them to communicate but do quite specific things? And also to use Node in its sort of maximum, right? So if you will allow me some shameless advertising, the people who were doing this project is reason they're hiring developers. They're looking for good developers. They also write good code. So you can visit that GitHub link. SLS Press is basically a framework that will allow you to, not in the way that I showed you by proxying, so you take your whole application and deploy it, not that way, but in I think a more efficient way. They allow you to set up routes. If you're used to Express.js, they can, you're used to this, you have a handler, you set up all your routes, you write all your functions in the way that you would with Express.js, except that all of this goes to AWS Lambda and you start leveraging the beautiful world that is AWS. I hope I haven't put you off by my pessimistic talk about how bad AWS, because it's actually really good, but I'm just trying to show the minefields, and I'm also just trying to sketch out the thinking that kind of inspired me to think about actually where do we go with all this. And I use Golang as well, for example, and Golang's perfect. You can write like a series of instructions, it runs very fast, it's very good. But I think when it comes to Node.js, as JavaScript developers, we are, and I'm not trying to with all due respect, we're kind of all over the place when it comes to conceptually thinking about things, because that's kind of the power of Node.js, that you could potentially do anything you want to with JavaScript, but there's a danger to that, in which we kind of murky the waters of the concepts of programming when we get into specific things like this, and that's exactly what happened with us. And so that was the talk. I hope there's a lot of food for thought and questions and so on. If you have any questions, I'd be happy to take them.